Welcome to my talk, Why Should I Actually Do Modeling? Subtitle, Challenges and Paths to Succeed with a Modeling Approach and How to Achieve Maturity in Modeling. My name is Horst Kargl. I'm Head of Training and Principal Consultant at SparxSystems Central Europe. SparxSystems Central Europe is a sister company of Sparx HQ in Australia. And we are also part of, I'm do modeling since 1998. I'm a former researcher at the Vienna University of Technology. I'm working for SparxSystems already since 2006 as a freelancer, but I joined Sparx in 2008 as an employee. And the domains I'm working in is model-based software engineering, systems engineering, and also enterprise architecture management, as well as data management, so which comes in all the domains. The modeling languages I very often use in my daily practice is UML, SysML, BPMN, DMN, Archimate, and NATO Architecture Framework 4.0. Yeah, and SparxSystems Central Europe is also part of the LIBA group, which also consists of Sparx Services Central Europe, LIBA, and Syntable. Good. So now let's talk about models. Yeah, not this kind of models. We're getting closer. Yeah, we're almost here. Yeah. Also, text actually is a kind of model. In the future, we will see SysML v2 coming up, and SysML v2 has also a textual notation. But even just natural language is also a kind of model. We represent the reality in natural text. But the models I'm talking about is actually this kind of models. Yeah, so these boxes and lines. So we distinguish here behavior and structural modeling. Why do we need models in industry? Yeah, the point is that the world is going more and more complex. We have bigger teams, we have distributed teams around the globe. We have bigger projects, more integrated, more complex projects, and we need other approaches. We need additional tools, other approaches to cope with this complexity. And therefore, we use different languages. The most common modeling languages I already mentioned, like UML, SysML, Archimate, BPMN, DMN, TOGA is actually a framework, yeah, but goes close with Archimate. These are the most prominent languages we use in our daily practice in industry. In different domains, I mentioned them already, like software engineering, systems engineering, and enterprise architecture. And in software engineering, we very often use UML. Of course, the origin of UML is software engineering. And in systems engineering, very often SysML is used, but not always. So we have also a lot of clients who use just UML for their modeling. So let me change here a little bit. Be better. So, yeah, in enterprise architecture management, data models is very often a big topic, but also UML is very often used to do data modeling. But in enterprise architecture management, we have dedicated languages like Archimate or the framework TOGA for BPMN and DMN, which goes more into this domain of enterprise architecture management. And data management, by the way, is a vertical approach. So this is used in all the different domains. And then there is the new SysML v2 coming up, which I think will be kind of a game changer, at least for the tool vendors and for the possibilities we have with modeling. Because SysML v2 has a completely different foundation, so it is based on a different meta model, not UML anymore. It has a more mathematical foundation. So we are looking forward to see SysML v2 also in practice and in different tools. Yeah, but actually, what do we need, or what the companies in practice need? So they have different stakeholders, and they just want answers. Yeah. And for these answers, they need data and information. Usually, they have used since decades this kind of tools, like the Office suite, Word, Excel. We very often see Excel specifications and Word specifications with attached with PowerPoint and Visio pictures still in industry, and they would like to go away from it because the world gets more and more complex. So we have to deal with this complexity. A few years ago, I was at Volvo as a consultant, and I saw an internal presentation from their head of whatever development, and they showed a picture that these days, a few years ago, software in cars was just more 10%, and then he showed an exponential curve where in future software will be 90% of the car. Yeah, now it's 10, but in future it will be 90%. So there's a lot of complexity in it and a lot of software and systems engineering. Good. Let's start with the easiest specification, like a textual specification done with Word. The question is, what does this text describes? And if I give you a few seconds, we don't have so much time to read it, you may get the idea of this description, but maybe you did not see that this text has already redundancies and ambiguous information in it. Like the blue part is really redundant, so it's the same sentence appearing in this text and maybe on other pages as well. So the problem here is if we would like to change something, we have to find all the sentences. Of course, in Word, we can use find and replace if we know exactly what should be replaced. But the second problem is ambiguous information. The orange one sounds similar. So the loan is removed from the system, or the requirement, the request is deleted from the system after 1 week. So does it mean the same, or is it just something similar, but semantically different? How should we cope with this? So that's a problem with textual specifications. So we have a lot of ambiguous information in it. And if you would like to change something, and you can imagine in industry, they have specifications with hundreds of pages. So I was once the client and as a consultant, and they also started going to work with model-based approaches. And they showed me a specification. It was thick like 1 centimeter, a few hundred pages from another team. And the software team tried to implement it, and they tried to model it. Yeah. And in the first 5 pages, we found already 3 or 4 inconsistencies, just because text had inconsistencies, ambiguities. Good. If we go with a model-based approach like this, it's much easier, I guess. Yeah. So here we don't have redundancies, or we would see them immediately, and we quickly understand what it is about, even if we don't know the model. So we see these arcs, and we see there are arcs coming in, and it's called end, and there is something called start. So it looks like a process. We can read all the steps. And we see that this here is this get book status is called at least 2 times in a loop, maybe more often. So we don't have this redundancy. So we see that this is, if I would like to change the get book status, I do it here, and it's changed in all situations. So if I generate a document out of this, the get book status can appear in multiple places, but it's always the same source of truth. And if I have the right tooling, let's see if it's working now. Unfortunately not. Okay, so this should be a video, yeah, and show you the simulation of this BPMN. And if you have this kind of tooling, you can also use models because they depending on the modeling languages and the maturity of the model and the tooling. You can use the simulation to semantically check the model, and you can get a better understanding of the specification if you just execute it. Even if you don't know the language and know what's happening here, if you execute it, you get a better idea, and you can explain a process and prove if it's done right. So once again, I'm trying to will not start. Okay. So we are talking actually about this line here, and you may notice this is the DAKY hierarchy by Danny P. Wallace. Actually here I have the SDIK without the W. W is wisdom. So I added the symbol. It's well known. So we're dealing with symbols, data, information, and knowledge. So because we have different symbols like this here, V, I, M, C, L. If I give you a context, you may understand this. If I tell you that this is a Roman number, you can read this number, V, I, and so on, and figure out that this is 8.6.1.955. If I give you another context and say, okay, it looks like a date, yeah, and it's a birth date, yeah. We have already an information, so this is not just a date; it's a birth date. And if I give you another context, you have knowledge. If I tell you that this is the birth date of Tim Berners-Lee, you know that Tim Berners-Lee becomes 69 this year. So with this knowledge, we can make decisions and do whatever we like in software systems and enterprise architecture management. But we are doing it with different symbols. So we have graphical modeling languages. So these are the symbols we are using. And the data are represented by these symbols. And then, depending on the context, so the view and the viewpoints we have in different modeling approaches, we have the knowledge we need for our decisions. And there are existing approaches, like one of the oldest frameworks we know is the Zachman framework. It comes from enterprise architecture management. So it has rows and columns, yeah, to describe the information and data of a company. And then there are also other frameworks. Here in the slides, I have mostly the enterprise architecture frameworks, like Toga for Archimate. It's also a framework and a language. They fit together nicely with Toga, but there are also frameworks in systems engineering and software engineering. For instance, industrial best practices of software engineering is ARC42. It's a kind of a framework, or SysMod or SPAS 2020 in systems engineering, or Harmony from IBM. It's also an older approach, but still valid. So this helps us already bring the view and the viewpoints and structure in our modeling. So actually, what the industry currently still is doing is going from a text-based approach to a model-based approach. Yeah. Sometimes they start already combining it, so they're using Visio with a plugin and they do UML or SysML. Yeah. But it's just a picture still. Yeah. So there's no actual model because there's no model repository, and the benefits of a model cannot be really used. So on the left-hand side, we heavily use languages, natural languages like German or English. And on the right-hand side, as a tool, we are using modeling tools. Yeah. So here we are comparing the text-based approach to the model-based approach. And one of the benefits when you go with a real modeling tool is that a model itself, like UML or SysML, BPMN, whatever, is actually structured data and with a standardized visualization. And these tools, the modeling tools, allow us to visualize this data. And most of the tools provide use cases which automate something. So we can automatically process this data. Good. But when we compare these two approaches, so just what dimensions we have to think about when we go with text or model-based approach. So first, we have to master the tools. So we have to know how to work with Excel, with PowerPoint, and so. And we use them for decades, so we know it. But when it comes to modeling tools, maybe it's not that easy. Next, the languages. Hopefully, we can speak German, English, Spanish, whatever, Japanese. But if we don't know the modeling language, so it's like, yeah, learning. If I'm a native Austrian speaker and I learn Chinese, yeah, so new symbols, new semantic, and everything is new. Yeah. So we need to master the language, and then we need also to think about the structure. So we need to think about the structure of the document or the Excel sheet. So how the sheet is organized. On the right-hand side, we also have to think about how to structure the models. Yeah. Like modeling languages, like general purpose modeling languages like UML, SysML. UML has 14 diagrams and actually 13, which are really used, yeah, or just 6 subset of it. In SysML, we have 9, yeah, also 6 or 7 are usually used. So we have not just one model, we have a lot of different models and how the models fit together. Next is how to cope with the details in the abstraction level. So this is also a huge challenge in industry. So whenever I give a training for modeling, the attendees, at the end of the 3 days, they get shocked out of the room and say, wow, I should do all this stuff, yeah? But the problem is, no, you don't have to. Just what you need, yeah? And another problem is that the engineers, they have so much knowledge and they think they need to put everything in a model. Yeah? So they over-engineer or put too much information in the model, and the problem is that they need to maintain this model and keep it up to date, because if the model is not up to date, you can throw it away because it has wrong information and nobody will trust the models anymore. So you spend a lot of effort putting all this information into the models, but nobody will use it because there is no trust in the model. So best is to really start short and on the high level of abstraction. Do not put too much details, because a more abstract model is not so often changing. And then the next problem is, okay, how to cope or how to describe the problem or the solution of the problem. Yeah. So these are the most common dimensions you have to think about when you go with a text-based, but also with a model-based approach. And if we compare the effort now, and there's no rocket science behind it, it's just our experience from 25 years in this domain. And if we compare it, you see that, okay, when you go with a model-based approach, it takes much more effort. Why should I go this road? Yeah. So we have to learn new tools. Like if you go with a modeling tool, it's like if you know Paint and you start now working with Photoshop. Yeah. So you need completely different concepts. If you don't know masks and layers, you're lost in Photoshop. Cannot use it. Yeah. It's the same with a modeling tool. So if you're used to work with PowerPoint and Visio, you draw pictures, but modeling tools work differently. The same with the language. So if you don't know UML, SysML, B command, yeah, you have to learn a new language. And by the way, there is also effort when you already know German or English, even if you're native. If you write a specification, a requirement specification, there is a specific way how to do this. So, and maybe you have to learn this as well. Yeah? So there's also effort in this. So the effort pays off if we go with modeling approaches when we use modeling tools, because the modeling tools provide, if I use them right, of course, a lot of benefits, a lot of automations, and leads to maybe a more agile model. And for the language itself, of course, if you would like to use UML or SysML also with Visio or PowerPoint, you have to learn them anyway. Yeah. And if you use a modeling tool, the modeling tool usually supports you creating a correct model. Yeah. So usually the modeling tools have kind of validations, at least for the syntax. And it's always good to go with standardized languages. Yeah. Because in recently I was at the big company again, and they had a lot of models and just boxes and lines, sometimes with a legend, yeah. But you always have to ask, what does this box mean? Why is it green? Why is it red? And why has it a red line to the other box? And why is this green? Yeah. So there is no semantic behind these boxes and lines. If we use a standardized language, we have already more clarity. So it's easier to communicate. It's easier to train the people because if you have learned it once, a standardized language, you can use it everywhere. Yeah. And yeah, the last 3 points are actually exactly the same what you have on the left-hand side. So if you write a document, you have to think about exactly the same points here. But the challenge here is you have to do it with a new tool in a new language. Yeah, so that's the challenge and the extra aspect. Okay, so what is now the benefit with a model-based approach? I mentioned already that we have structured data with a modeling tool. Usually the modeling tools have kind of model repository, depends on the tooling, if it's a database or if it's just a file loaded in memory. And also depending on the tooling, but usually there is a possibility to work in a collaborative way with these models. Yeah. And the first low-hanging fruit is we don't write the specification, we just generate it. Yeah. Again, we put all the information in the model repository, and here there are, of course, a few questions of what is the modeling approach, what is the structure, what level of abstraction, what data should be used for which stakeholder. So a lot of questions, yeah. But if we have an approach, then we can just press a button and generate 5 documents with 1,000 pages, yeah, without any effort. And if we change just a little aspect, if we did it right, we have just one single point of information in the repository. So we have one change and we regenerate the 1,000 pages, and we assure that they are consistent and complete based on the information in the repositories. And of course, we also can generate other documents like source code, XML schemas, database schemas, and we can also import and maybe round-trip engineering. And generate also other kind of documents like test cases, test handbooks. We can also generate models from models. And in practice, there is no single standalone tool, so everything is somehow integrated. By the way, yeah, SparxSystems is developing and selling a modeling tool or a bunch of modeling tools, a modeling tool family. And everything what you can imagine can be done with the tool enterprise architect we are selling. But many of our customers says, yeah, okay, but we have another tool for requirements engineering. We don't use enterprise architect for it. But is there a possibility to integrate? Yeah, so that's an important point in industry, that this interoperability between the tools and data exchange is really important. But of course, you need to think about garbage in, garbage out, yeah. And so if you just load something, an Excel file into a model repository and wait for the magic, yeah, it may happen, but maybe not. But you can do a lot of things with the models inside, like we can do model validations. If the models are loaded in this modeling tools, we can use the features of the tools to validate the model because we have structured data. We can simulate it. We saw it already. We can execute it and prove if the model is correct from a semantical point of view. And we can do any other automations. So most of the tools out there have APIs, have different interfaces to extend the functionality and build something on top of it. Yeah, but the most important thing here is that we have rules and guidelines. So, because otherwise, the implementation, the features, the automations here needs to be very generic and be able to cope with any data. So then we have to put a lot of effort developing these automations here. Or we say, no, we just have a modeling approach with specified rules and guidelines, and then it's easier to develop and maintain all these automations. Yeah. Of course, by the way, many of these automations come out of the box by modeling tools, but in practice, yeah, it's like I very often get requests from customer when I do trainings. Why is it not built into the tool? Yeah, this feature, whatever. I always say that okay, here you have the API and you can do this and that. Yeah. The question is, why is it not built in the tool? The answer is pretty simple, because yeah, if I do it the way you would like to have it, the 9 others say, yeah, I need the same, but the opposite way. Yeah. So if you implement a specific method in the tool, you make one happy and the other 9 craving for something, and yeah, you cannot satisfy all the different requirements. So at least we at SparxSystems, we changed the approach and say, okay, we provide a powerful platform, a powerful modeling platform with a lot of APIs and possibilities, and then you can build whatever you like on top of it. Okay. Yeah, with these rules and guidelines, we can achieve many things, but actually modeling languages have a meta model with a lot of rules and guidelines and constraints. Isn't it enough? Unfortunately not. Yeah. Point is that the language itself is just one dimension, which is important. But we have much more dimensions. Like when we go with model-based approaches, one dimension is the tooling. Yeah. Because for a genius without a tool is not productive. So we would like to be productive in practice. The other dimension is the modeling language. Yeah, because a fool with a tool is just a fool. So you need to know what to do with it. Yeah. Third dimension is the modeling approach. Now we are coming closer because we have the tooling, we have the modeling language. The tools have a lot of possibilities, and the language has a lot of possibilities, and we now have a huge open space we can use for our specifications. And you can imagine, even if you work alone, it could be challenging if you work on a long period on the same project, because you get more and more advanced, you get more and more ideas, and maybe 3 weeks before you solve the problem differently. Yeah. Yeah. Here, to get the proper modeling approach, you have to have these 2 questions in mind. So who reads the model and what information should be read to prevent over-engineering and really hit the interesting points. Yeah, because a genius without a plan is lost. So we need a modeling approach, and we need to know how to combine this tooling and languages. And then there is a fourth dimension. It's experience. Experience means, yeah, just do it, learn from your mistakes, make mistakes, and learn from your mistakes. Or better, use best practices like existing frameworks mentioned already, Sachman, ARC42, SysMod, SPES 2020. There are frameworks which are well defined. There are books about this. But I saw also in practice, and that's my approach. It's good to know all these frameworks, but you have to customize them. Nobody will use an approach from the shelf. So the book, like Rational Unified Process, a huge, big software engineering process. But if you follow all the steps, maybe there is no stakeholder for some of these steps. So you always have to adopt it. It's good to know the approaches, but you have to adopt it to the needs. So who reads the model, or who needs any information? Who are the stakeholders? and what answers the stakeholders need. So yeah, genius without with no experience. So that's the reason why we need experience. Invents the wheel over and over again. Yeah, so if there is already an approach, just read it and try to use it and adopt it, and don't invent the wheel over and over again. So when we think about now the modeling approach, with these two questions in mind, we distinguish method and process. The method is first, okay, we need to know which modeling language suits best for this problem. And further, what elements should be used to express which data which become information, we bring it into a context. Which connectors should be used? Well, with the connectors, we have the context. Yeah. So if I use this element with this element and this connector, we have the context. So we have this, we have the information. And if you know the general purpose languages like UML and SysML, you know that you can solve the same problem with different models, different approaches. Mostly there is no right or wrong. It's just good or not that good, or maybe worse. Sometimes it's really incorrect because you have used the connector in the wrong direction, so it's syntactically not correct. So you have a different statement as you actually would like to say. But usually it's just, yeah, it's good, or I would model it differently. And to prevent this, it's good to have the subset of the language. And yeah, connector rules, yeah. Like which element is connected with which other element. Of course, this is defined in the modeling language, but sometimes we would like to narrow it down. We would like to reduce the possibilities, the complexity of the language. And if we miss something, yeah, we can. If we go with UML-based models or modeling languages, we have the possibility to develop UML profiles with stereotype and tag values. So we add new terms and new properties, new meta information to the element. This also is possible with SysML v2, but a little bit different way, but also possible to extend the language. And then, which comes more to this modeling approach again, how to structure the model. So what packages do we need? So we are now, when we compare text to model-based at the structure part, yeah, we use packages, and then which package should contain which element. So how to slice the different models with reusability in mind, and maybe versioning, baselining in mind. And then additional rules and governance guidelines. Yeah, so here we have the first bullet points are the DSL, which doesn't necessarily mean that we develop a completely new language. So we should stay with the languages we have, so the standardized languages, and just extend it. Because if we invent over and over new languages, the point is who will use these additional languages, because usually it has new syntax, has new semantics. And if I know already UML or SysML, even that is hard to bring into practice, that the industry is using this kind of languages. If you come around the corner and say, hey, I have a new language, they say, I know UML, why I can't use UML already? Yeah. But if necessary, yeah, if UML, SysML, whatever is too weak, we have to define something new. Yeah. Second is the model structure, and then the governance. The process part is pretty simple. Yeah. So we need kind of process. So which artifacts, which model element should be created, when, and who is responsible for it. So that's the process part, and that's what we call project meta model. So there's a language meta model which defines the modeling language, the semantics, and the syntax of the language. But this is the meta model for the project, for the modeling approach. Yeah, which yeah, if you don't follow this approach, you can easily end up with a model like this, which is a completely correct UML or SysML model, but it's just a mess because too many people have solved the same problems in different ways. Yeah, so there is no real structure. And it's really hard to automatically process this data. Or you have a really, generic approach or kind of AI, which somehow heuristically gets something out of it. Yeah, so the point, the challenge is, thank you. The point is that we have a modeling language, and we should create a subset of it. Yeah, just what you really need, and if necessary, extend the language. So that's the DSL part, and then the model structure part is okay. We need to think about the packages, how to organize the model, especially when you think about reusability, component building, library building, versioning, variant management, and so on. Slicing of models. So this is an important part. And here we have to think about what packages do we have and what elements should be nested in which package, because a model is a graph. Right? If you put it in packages, you have always these cross-package dependencies, which has an impact if you slice the model. Yeah? You will lose information depending on the tooling again, of course. But if you pull out one of the boxes, put it somewhere else, maybe you've lost information, depending on how the pull out is working. Yeah, and then we have the governance, and the modeling languages have their rules and guidelines, but we can also extend them. And of course, if necessary, we can come up with completely new languages. Like the SysML v2 initiative is now a completely new language, which follows the semantic of the languages we know already, like UML. So in SysML is based on UML, so it's a UML profile. So all the concepts we know from these languages, from an ontological point of view, can be found in SysML v2 as well. But just the structure and the possibilities of the language is different. So we have completely new language. Okay. Now I would like to give you an example how a modeling approach can be developed with these two questions in mind. So who reads the model and what information should be read? And in order to derive this modeling approach, you need to formulate questions. And the more questions you have, the maybe not easier, but you need questions to come up with a modeling approach. And here I have a simple example, like if there is a stakeholder who needs to know what signals do we have in our system, then we need to think about how to model this data in our model. Yeah. So then we think about what language could we use. So we stay with UML here. UML has an element called signal. There's a perfect match. So we can use signal elements to express signals. If someone would like to know what signals do we have, just query all the signals in the model, and then you know the signals. If there is another question, who receives the signal, we can think about, okay, we started with UML. Let's try to stay in UML, and how can we model the receiving of a signal? And there's a dedicated model element for doing it. It's the reception of the class. Yeah, the reception says that this class is able to receive this signal, my signal. Next question: who sends the signal? Again, we can think about stay in UML. In UML activity diagrams, we have something called send signal action, which references a signal and says, okay, in this process we're sending a signal, and this process can be contained in another class. So now we know that this class is sending the signal. So well done, But if you have more experiences, you may come up with a different solution. So here, I have just used an information flow. The information flow has an information item which references the signal, and we have our two classes, and I can answer the same questions. The model is much easier to create, easier to maintain or to get an answer, because on the left-hand side model, the sending of a signal is pretty hidden in the model. Of course, with the right tooling, you may get it also quickly up, but it's more effort to do it. By the way, there is also another approach, like you can also use a sequence diagram for showing the signals. Yeah, more or less similar to the right-hand side. Okay, so what this is the reference model. So we try to sit together with the customer and say what your stakeholders need. Give me the questions, and then we try to sketch a model and see if this model working. Yeah. And if yes, then we have the reference model, and then we can derive the project meta model. We try to make it more abstract and say these are the rules now. Now try to work with this. So if here we have the rules and guidelines, and if we go this way, we can assure that we do not model too much or too complex. Yeah, and we can assure also that every model has a purpose. So there's no over-engineering, because there is beneath any of these symbols there is a question. Otherwise, we wouldn't model it. Yeah, and we have found the easiest solution. Of course, here we need the experience. But if we have more questions, maybe this is not enough anymore. But if we have followed the rules and the model is structured this way, we can use automations to automatically transform this model into the left-hand side model, and also keep it in sync. Yeah. Like if I create an information flow with a signal, the reception and the send signal is created, or if I delete it, it will be deleted. Or before I delete it, I will ask if I should delete it. Okay. So, how to fail? So we saw also a lot of approaches failing. So when I come to the customer, I sometimes get the information, yeah, we have tried it 10 years ago, we failed. Now we would like to try it again. So 10 years after, new team, some water down the Danube, and let's try it again. Yeah, and this is our experiences we found. So there are different approaches. The first one is someone starts doing modeling, rise to a specific level of benefits, and then the approach died. The problem is that the model looked like this. Yeah, and maybe so this approach very often dies if I'm starting modeling alone, and then I spread it, and I work with a colleague of mine together. The colleague says, no, I can't cope with this. So I have no idea how to work with this model. Let's go back to Excel. So because we have a time schedule and we need to finish it, and then the approach died. The other one is we get the expert, and the expert says, yeah, you have to go this way. I wrote a book. This is how it works. Yeah, and teach the book. Immediately died if the approach was too complex and there was too less support, which means maybe tooling was not trained enough, or the modeling language was not trained enough, or the approach was not explained enough, or there was no help from the tool. Like, you have to read the book, which is 500 pages, and you have to follow this approach. And if you do something wrong, someone hits you on the hand and say, okay, you did it wrong again. So, but if the tool teaches you on the go, maybe then this could work. Another way to fail is if you are too ambitious and try to reach a strategic aim. So next year, in end of 2025, the whole company will be model-based. Yeah. So the first row, you're the experts. You have 1 year, finish it. Yeah. And next summer, we get the new big client. So, but I need all of you, because you are the experts, and this is a really big customer we have now. But you're not finished. Yeah. So there is nothing which can be used. So half a year or more money spent without any benefit. Yeah, the all-at-once approach. So like in software engineering, agile iterations, also by developing the modeling approach, it's better to go in an iterative way. Like, think what is the biggest pain we have to solve and try to find a model-based solution for it, implement it, and roll it out, not in a too big team, but test it forward. Yeah? The problem is if you roll it out in a too big team, it could be that this approach was not the best, and then you have to roll back, and then you will get problems with your team. Yeah? Because then a month later, something is changing, and then you hear the voices that, hey, they don't know what they are doing, so they change everything. Every month is something new, and I don't know what I have to do, and I go back to the next. Okay, so, and then you can iteratively evolve the approach, and maybe you reach a completely different goal, of course, later, but this is something which is really helpful. Okay, and for developing this, we have also a kind of meta process. Like here we have first, of course, the customer needs to know the basics, which can be done in a basic training or basic workshop. Okay? Workshop is more, okay, we have this idea, we would like to achieve this, and now let's talk about it. Training is, okay, I have no idea, I just heard modeling is good, and I would like to go this road. Yeah, first need to bring the basic knowledge. And then the important part is you need to, in order to develop this modeling approach, you need to ask your stakeholders, what problems do you have? What questions do you would like to have answered? And this is also very challenging because the companies are doing it for decades. Yeah? And if I ask them, what does your engineers need? The answer is very often, I need a good architecture description. Yeah. Okay. More precise, please. Yeah. So what actually is the information? What is the data you need? Yeah. Is it the signal you're interested in? What kind of signal? Is the payload of the signal important for you or not? Yeah. So this kind of questions. Domain model is also very interesting and important. The domain model is like an ontology, very often done with a class diagram. You just have classes with terms and relations to express just knowledge. I was once at a client, and there was this old big knowledge guy who did whatever they developed for 20 years, and then the youngsters and the experienced one told, okay, this and this is how the system works. We modeled a domain model, and then the youngsters all say, yeah, okay, now we know how the system works. But the day after, we talked about a different functionality of the system, and one of the younger employees said, but how you explain it now doesn't fit to the domain model from yesterday. So even the really experienced engineer had multiple pictures of the system he's developing for 20 years, depending on the functionality he's thinking of. So there's no common understanding, even in oneself. So that's the reason why it is really important to have a domain model for a common understanding. So here we have the required information we need to develop the modeling approach. And then we can try to find existing approaches, frameworks, which can be used, can be adopted. This leads to the reference model, so the example. And then important part, we have to stress test this. Yes, stress test this. First row has developed something after 1 week or 1 month. The second row tests it and gives feedback, not the whole classroom. So we do the stress test, and it could be that in the stress test, we find out that we have to optimize something. Just tweak a little bit or add an automation to the tooling because it's cumbersome to do all these links or to get the answer of a question. Yeah, write something which brings you the answer, a query or a snippet of code which calculates the answer. Yeah. So, and here we could have iterations, of course. So, because maybe in the stress test, it turns also out that maybe the framework we have used is not the best one, and we have to make one circle. But the output here is now the project meta model, the configurations of the tools, and maybe automations, which makes life easier. And that's the modeling approach. And with this modeling approach, we can now start training the people, or preparing a training, a customized training, and train the people. Because then they don't have to learn everything from the tool, from the language. They just need to learn the subset and the method. So that was the modeling approach. But the question is, am I already mature enough? Or is the modeling mature enough? So how to validate the modeling approach? How to measure maturity? And we would like to get mature. We would like to have a degree or a certification that you did it the right way. So a few years ago, we started with a kind of modeling maturity model with 4 stages. First stage, it's the version 1, because currently we're working on version 2. Version 1 was, okay, you have one modeler modeling for himself, just to get a clear understanding of his engineering tasks. Second one, we are already working in the team, and you're already on stage 2. We are working on the same one together. Third stage is that we have multiple modelers, and not just modelers, we have also model consumers. And here we have different roles on top. So we have the model experts. These are the guys who are driving the approach. The others are the model citizens, which do the hard work. They provide the data and do the modeling stuff. And then there is the model consumer, because most of the people in the company are not interested in models. They are just interested in the information of the models. And they would like to not see the modeling tool. They just want to have an answer for a question. So therefore, we need additional tools, maybe aggregations of the data in the model. So this is the third stage. If you have reached this, then you're already on stage 3. And stage 4 is, again, you have multiple modelers, you have multiple consumers, you have staging of the model. So you have already versions. So as version controlled models, we are already more on the safe side. You can do staging, you have branching and merging using existing version control systems. Good. Did we miss something here? Because this was the first approach of this modeling maturity model. But then very early, we raised the question, okay, if I'm working alone, what if I also use version control? I could do this. Am I still on level 1, or I'm already on level 5 because I'm using version control? So there are more possible combinations of different configurations. Question is on which level we are if we have different features enabled or capabilities in our modeling approach. So, and I quickly show you how far we currently are with version 2 of this modeling maturity model. The modeling approach itself has a maturity model in itself. Like, we can do ad hoc modeling. So we're just using modeling languages for sketching. Of course, we're using modeling to get the benefits of a modeling tool, but we are just ad hoc modeling. So we have no plan, no approach, actually. The next step is we have structured modeling. So we combine already different views. Third step is we have a dedicated meta model, but it's just in the handbook. It's not in the tool. And then fourth step is we have assured modeling. So the tool implements all the rules and teaches me the approach. And the fifth approach is we are really on the level for agile modeling. So the tools also support me with a lot of automations. If I go the one direction, I can easily go back and go in another direction. Version control, for instance, is one, wizards and other automations is the other. And then we have this model data management, which is an important part where version control plays a role. Collaboration, so how to collaborate with smaller or bigger teams, and then the stakeholder skills. Yeah? You know the 4 dimensions. Yeah. So the 4 dimensions of the stakeholder skills leads to different combinations. This is not all the different combinations we can have. Yeah. So here we have 4 levels of 4 skills level: unskilled, minimum skills, mature, and expert. Yeah. And here we can have different combinations of skillness. And then when it comes to model data management, we have to think about we have different possibilities. So we can have versioning, we can do horizontal, vertical versioning, access rights, so model visibility. If a team accesses the model, is it allowed that everyone sees everything in the model, or do we need to hide something? How can we hide it? Is it important to slice out models and put it in another repository, which is another possibility, slicing of models, or tool integrations, variant management, publishing. So these are the topics you need to have in mind when it comes to model data management. When it comes to collaboration, we can work alone, we can work in a team, and a special kind of working in the team is a supply chain. Working in a team on the same model, or I get a model from someone else, work with the model, and then push it forward to someone else, and so that's the chain of models. And then the model consumer, other stakeholders, which collaborate. So, and then we have at least 3 to 4 dimensions. So the left part here is the skill level, which actually can be applied to all these 3 domains, and then we can make different configurations. Like there is one which is ad hoc modeling, which with version control, with modeling on your own. Yeah. So this is the secured sketch, secured because we use a version control system to have versions. So whenever I change something, I can compare it to my previous version. I can undo changes, but it's still a sketch. So it may be this mass model. If someone else is coming to work with me, maybe this works not out. Yeah, good. And now we are coming to this indifference curves of possible configurations. Yeah, which is this. And the question is now, what configurations, possible configurations leads to which experience levels? And this is where we are currently working, and we are finally done. Thanks for your attention, and let's dig for the goal of or benefits of model-based approaches. Thank you.